Hello and welcome back to Blackbird. This is Venkat, and in this video, we'll be talking about arrays in Java. Arrays serve as the most fundamental data structure when it comes to any programming language and not just Java. And hence, knowing about it in great detail is really important for the betterment of your problem solving skills. Arrays form a foundation for other data structures like linked lists, array lists, stack, queues, circular queues, DQ, as well as some other data structures. So knowing about it is important, and hence we shouldn't be wasting time. Should start right away. I'd like to start with an example where you are a monitor of a class, and you have been assigned by your class teacher that you have to create a program which accepts the name of any student out of 53 students and display the total marks out of 500 with the percentage corresponding to their name. And you are given a list of names with the total marks out of 500 for 53 students. There can be two approaches in which you can solve this program. A very naive approach would be to create 53 variables separately for storing the names and for storing the marks. So in total of creating 106 variables. But somebody from your class suggested that you should go for a collection rather than using so many variables. So the application of arrays comes in when you have a huge number of storage elements, huge number of elements to be stored, and there you just can represent these huge number of elements with just one variable. This is where the mentor's zindagi comes in, and that is what arrays is in Java. Talking in a definitive way, an array is an ordered collection of fixed number of homogeneous data elements. Okay, now let me break this down into simpler terms so that it'll be easy for you to understand. Ordered collection, it means for every value stored in that array, there is a unique index corresponding to that value. That is what ordered collection means. Fixed number, it can store only specific number of elements. So it's like if you say that you want to store 53 student names and their marks, you can at most store only that number of elements. If you want to add one more student above 53, it won't be possible because arrays are fixed in size. Homogeneous data elements. So this is really easy to understand that all the values that you are going to store in that array should be of the same data type as declared by the programmer or as declared during the time of array declaration. So what is the structure of arrays? How internally are arrays stored in Java? Arrays can be visualized in this way, but before visualizing it, let me tell you how to declare an array. That's the foremost thing that you should learn. So there are many type of arrays. There are multi-dimensional arrays as well. There are 1D arrays, 2D arrays, 3D arrays. There are jagged arrays. But at this point, firstly, we want to talk about 1D arrays. What are 1D arrays? 1D arrays can be visualized as a sort of a table, a horizontal table, with a lot of cells that are present, which can store values, and there is index based on that. There is one great thing that you should notice is that the indexes begin with 0 and they end with n minus 1. So let's say for a length of array n, the range of array would be from 0 to n minus 1. Okay, where n is the length of the array. So how to declare a 1D array? Let's say you want to store the marks of those 53 students. So you would say int and a pair of square brackets which denotes the dimension of the array, and then you would simply write the variable name marks. This is it. This is how you declare a 1D array. Now you have already declared a 1D array, but the compiler is like, bro, what is the size of this array? Or how many elements are you going to store in this particular marks array? So for this example, since we have taken 53, we would be specifying 53. So when we are initializing an array, it's something like this. You might be confused here for a while because, and even if you're not, but you should have this question that int is a primitive data type. So how is it possible that we are using the new keyword in order to initialize an array of type int? This is because the data type int is a primitive data type. But anything apart from those 8 primitive data types in Java are objects, are treated as objects. So arrays are also objects. So be it of a primitive data type array or be it a reference type array, both are objects. And hence for every object you have to instantiate it with the help of new keyword. And that is why you won't get any compilation error here, provided that you actually are declaring an array and not something else. You should note this because if you don't have these pair of square brackets which denote the dimension of the array, you won't be able to use this new keyword and it will give you a compilation error, because the compiler does not expect primitive data types to be instantiated but only the reference types. Array comes under a reference type. So here, continuing, what the Java compiler does is it creates a array. Okay, in the heap memory it creates an array, sorry for my drawing, which has a horizontal you can visualize it as a horizontal table which has 53 columns, and the range of this is from 0, 1, 2, 3, all along till 52. And then this variable marks, it stores the location of this particular array. It stores the memory address for this particular array. Initially, when you initialize the array with this size, what happens is the default value is being fed here. So the default value of int is 0, and so the default value is filled in this horizontal table or horizontal collection, which we call as an array. Once you need to store specifically a particular value at a particular index, you can refer it to as marks, and within the pair of square brackets you can mention the range for that particular address, for that particular memory location, and you can assign some integer value to it in this way. Now, there is one thing which is very notable, which we'll be seeing in the practical session for arrays, is that you cannot declare size here. This part is solely the declaration part. Whatever happens is here. Okay, we'll see that once we go to the initialize to the practical session. We'll see that. So there are some bulleted points that you should note here. The first point, arrays are fixed in size. The second point, once the size of the array is declared, size cannot be changed for a given array. Okay. However, there are tricks to change the size of the array dynamically, what we call as a dynamic array. But for that also, you cannot instantly change the size of the array if there are more elements which are to be added above the size. The third point that you should keep in mind is that it stores the same data, it stores values of a particular type. Okay. Fourth thing, that it is a indexed collection. So which means that if you want to access a given value at a given position, so you can just access that value by saying that, this is my marks variable which stores the starting point of the array, and from their starting point I want to access the fifth element, so I will write fourth and I'll get the fifth element. Now why is there this controversy that I've said I want to access the fifth element but then I wrote here fourth? Why so? Now this is because it follows zero based indexing. Any data structure in case of programming follows a zero based indexing. So you should keep this in mind. You would see here it begins from 0 and it goes till n minus 1 as we discussed here in the range. Alright, let's move to the practical section to declare, initialize and to use arrays. So let me just enter in the presentation mode. Okay, we have a class here as array usage example, and as we said, our purpose is to accept, let's say, only 10 names of students and their total marks out of 500, and display them when the specific name is entered. Okay, so as usual, things are normal here. Then we begin with declaring an array in this way. Let's say I want to have a string array of names is equals new string, and since I specified 10, so I need to mention the size here. It's not possible if I mention the size here as well. No, it's not valid. It will give me an error. And what is that error? Let us check. That error is it expects an expression, so it's not allowed to enter the size here. Only when you are initializing it, you should mention the size. It's more of like, you initialize a class array usage example is equals new array usage example, and then you mention some, size or some values that need to be initialized before the rest of the program gets executed. This denotes that the arrays are fixed in size. Okay, now I want another array which stores the marks, and simply I'll say in this way. You might note that string is a reference data type. Okay, it is not a primitive data type, not at all, never. It's a reference data type, and we create an array of a reference type in the same way as we do for a primitive data type. In fact, if I show you one thing, you'd be shocked to see this. If I print the class, if I get the class of this marks array, and if I get the name and then I print this, let's see what output you'll get. This is really interesting to know because this resolves your issue that why with a primitive data type, how is it possible that we are instantiating it? And the output is a square bracket open and the start of a square bracket with a capital letter I. Now there is a question for you. The question is, once we declare and initialize a int type array, int marks is equals new int of size 10, and when we write or print the name of this array, you know this is done by getting the class and then getting the name. So once we do this, the output that we get is a square bracket open and then a capital I. How is this possible? Yes, it is possible. It's because for a integer array, this is the class of the integer array, but you cannot view this class. You know why? Because for every array type, there is a corresponding class which are available at a language level. You can use it in your programming language, but they are not available at the programmer level, and that is why you cannot see this class, but unknowingly you initialize an array of any data type. Okay, this is really important to understand. Okay, so let's say I draw a table for a int single dimensional int type array. The corresponding class name is square bracket open and a capital I. For a double dimensional array, for a 2D array, we give two pair of square brackets and the name of the class is square bracket I. For a double type array, it's the same, a single pair of braces and then open square bracket and a capital D. For byte, it is the same. It's a open bracket and a capital B. Only for the boolean, it is different. It is open bracket and the capital Z. Why? Because B for byte, B for boolean, but capital B is already used. So in order to avoid any conflict, there is this open bracket and capital Z. So for every type of array, there is a corresponding class name which is available at a language level but is not available at a programmer level. Okay, let's come back to our program and finish it. In the last video, we discussed about using a scanner class, right? This is how we use it, but we need to import it as well. So we write import java.util.scanner and it's imported. What we do is for 10 values, I'd say int I is equals 0, I less than equals names dot length, or I can simply say I less than equals this would be I less than names dot length, and then I'll say I plus plus. Okay, so try to enter name, then I'll accept the name here. Let's say names of I is equals sc dot next line, and here I'll enter the marks out of 500, and I'll here write marks of I is sc dot next int. Okay, now you see this is a for loop. I'll tell you about how exactly it works. Just for now, understand that we are beginning from the 0th index, continuing till the names like ninth index, and every time this body is executed, we increment the value by 1. Okay, so instead of I plus plus, I can also write I is equals I plus 1. Works the same. All right. So what we have done here is we have accepted all the names and the marks of those corresponding students. And now what we'll have to do is for each of them, we must say that we'll display the marks and percentage out dot println and name of student plus name plus okay, no, this will not be name, it will be names present at the ith index, and the marks would be plus marks at the index I. Very simple to use. Let's feed in the values one by one. Okay, so let's say Gotham, let's say the marks is 100, any random, Krish 23, Venkat 89, Aryan 67, Arshi 32, Neil 90, Rudraksh 100, Deepa 23, Arvind 36. And once we enter all the marks of the students, we get a list of all the 10 students, okay, like this, followed with the marks. This is how you deal with arrays in Java. So we completed our example. There are some other things that I need to tell you here. I'll copy this, bring it to the slideshow, and let's see if I have an option to write some text. Paste it here. Yeah, got it. So what exactly we are doing here? This is a for loop construct. Okay, It is a for loop. We'll talk about this for loop a little later. Just simply what it does is it starts from the 0th index, continues till the ninth index because the length or the number of students that we are going to store is 10, and then it increments one by one the name of this the index. Okay, then what we are doing is we are printing the name of the student, okay, which is present in the names array at the ith index. So when I is 0, I'm saying that I want to print the name of the student present in the names array at 0th index, and the marks of the student which is present at the 0th index in that array. So you can literally visualize this in the way as if I want to print the name of the student present at ith index in the names array along with the ith index in the marks array. So how does this work? When I is equals 0, what it does is it prints the name which is present at the 0th index, and along with the marks, which is marks of that particular student which is present at the 0th index. So when I is equals 1, the names, it remains the same, it changes to the second, comes to the first index, and similarly for marks it comes to the first index, and so on till I is 9, where the program after running, when the value increments to I is equals 10, this condition becomes false, and then this construct is not executed. The body of this loop is not executed anymore. I hope these things are clear. Let's talk about how to declare a 2D array. I suppose this video can go long just for a reason that I suppose this video will go long because just for the reason that there are a lot of things that you need to cover in this video, and that is why it would be a little longer than expected. So sit back and relax. Declaring a 2D array is as simple as declaring a 1D array, but there are some things that you need to know. You can declare a 2D array in this way. You can also declare a 2D array in this way, where the pair of square brackets is along or like after the name of the array variable. You can also declare a 2D array in this way and in this way as well. So there are multiple ways in which you can declare a 2D array, but the most preferred way to do it is in this way, to keep to keep the array variable separate from these pair of square brackets or from the dimension brackets. Now, this is just for the reason because this gives you a very authentic and genuine look that it is a two-dimensional integer type array. Here, what you would see is you would have to go through this entire statement in order to tell if it is a 2D or a 3D or a jagged array. But here you can directly say it because you're seeing two pair of braces along with the data type. You would say the variable array is of type int and it is a 2D array. And as simple as that. Initializing the same, let's switch back to the terminal. Let's see how we'll initialize this. Okay, let me just comment down this entire section because we don't need it anymore. And let's specify a two-dimensional array of type int. Array is equals new int, and then here I need to mention the size. Okay, for a matrix I can say 3 cross 3. So visualizing this, what will you get? Once declared, I declared the array of 2D, it is a 2D array. I declared a 2D array of type int, which has 3 rows and which has 3 columns. Okay, so if we have to visualize it, it will be something like this. let's say int square brackets and array is equals new int and square brackets, and within this I say 3, and here also I say 3. Okay, this would specify that there is a matrix. Okay, 1 2 3 4 5 6 and 7 8 9. Okay, this particular this first bracket denotes the number of rows, and the second bracket denotes the columns. Okay, and this is a matrix, I would say 3 cross 3, 0 1 2, and here also 0 1 2. All right, let's do something crazy with this. Let me say that instead of having this, I want to store the values within it, right during the initialization. So I want to dynamically initialize it as well. So what I can do is I can simply remove this section, and I can say a matrix having 1 2 3 4 5 6 7 8 9 and a semicolon, not to forget. What this does is it specifies that this particular thing that we are seeing, the first pair of curly braces that we see is the rows. Okay, it denotes rows, since like this 1 2 3 is in one row, 4 5 6 is in the second row, and 7 8 9 is in the third row. But the values 1 4 and 7 are in the same column but in different row. 2 5 8 again in the same column but in a different row. 3 6 9 same column, different row. Okay, so it'd be something like this. Here we have 1 2 3 4 5 6 7 8 9. In order to access the value 5, you need to say that you need to have the array value present at an index of 1, at a row index of 1, and at a column index of 1. Okay, so this is the address for the value 5. Let's say similarly you want to access this value 9. You would say, um, just a second, you would say array present at the index 2, like a row index 2 and a column index of 2, and you get the value 9. Similarly for this value, let's say 2, what we will say is array value present at the row index of 0 and a column index of 1 is 2. So you keep it in mind in this way. This is how 2D arrays work. Now let us study about 3D arrays in Java. 3D arrays can really be visualized as a cubical array, given that all the sizes are identical. The declaration of a cubical array or a 3D array would look something like this. You denote the 3D array with this notation: three pairs of square brackets, then the array variable name, then new int of any size, let's say 3 3 3. So what the compiler would infer is you are creating a matrix, something like this. Cell stores a value. But for our representation, since this is a compiler representation, it's a compiler POV, we'll have to create our POVs. So, what your point of view should be that there is a array, there is a 1D array, okay, from the 0th, first, and the second index. There are 2D arrays. Okay, let's say this is a 2D array again of size 3, 0 1 2, which where each of the index of that 2D array stores a 1D array of size 3. Something like this. What is the benefit of representing your 3D array in this way? Well, if you could see, accessing a value would have been really simple given this structure was there. In a cubical structure, you might miss one of the faces of the array, but here you won't because you're clearly seeing if you want a element at this particular index, then all you have to do is write array at index 0, 1, and 1. And then you can simply access the value present or the element present in this index. Similarly, to access this index, what you could do is you would write array of 0, 0, and again a 0. As simple as that. Since you are telling the compiler that at the 0th index of the first three-dimensional array, there is a 2D array, and again at the 0th index of that 2D array, there is a 1D array, and at the 0th index of that 1D array, there is the element that I need. So compiler, bring me that. And that's how you do it from your point of view. Alright, let us talk about jagged arrays. Did you know that you can also avoid these two parameters right here? Well, avoiding that would bring us to the topic of jagged arrays. Jagged arrays are multidimensional arrays which store a collection of various arrays, okay, of different sizes. So all you have to do is declare a size, let's say 3, and then leave these two spaces blank. Then let's say that you want to declare some 2D arrays. What you would do is you could simply write array at the index, at the first index. It should store a new two-dimensional array of size 10 cross 10. So it's going to be a matrix of 10 cross 10. All right. You can also say that array, a three-dimensional array at the index 2 would store a 3 cross 3 matrix in it. This is the concept about jagged arrays in Java. There is one topic that I forgot to cover in the entire lecture, and that is array.length. You might see that oftentimes I have used this name.length, array.length for my boolean condition in the for loop. Why have I done that? Why didn't I call the method length, but instead of that I used a dot operator and called this length for the array? This is because length of an array is a variable. It's a class variable which can be accessed by or which is accessible in the program level. So just remember that length of an array is a class variable, and length of a string is available at a programmer level via the length method. I'll also talk about this once we cover the string section. Okay. Length of an array is a class variable, and length of a string is used by or is found out by this length method. There's another thing that I should bring into your notice, which is a for each loop. The structure and the syntax of a for each loop is really simple. What you do is you write for, you write the data type, element name is to, and then here goes a collection. It's basically used to iterate over the elements present in a collection. where you only need the elements that are present in a collection. Okay, so let's say that for example, I have a int array and I want to iterate over all the elements of this one dimensional int array. So I would write for int val is to array, and then I'll just print the value. What I am saying here is for each value present in this particular array, I want to print that value. So this is another variation of a for loop, and it is really handy when you need to display values, or you need to perform some, you know, pure contract operations. And there is one thing though, you cannot modify anything, so it's only used either for displaying the elements of that particular collection, or in order to find out or iterate over the elements of that collection. But if you have to modify something and you need the help of the index, then you should always prefer the for loop. We'll learn about the for loop in the upcoming lectures, and it's like kind of noting one thing, which is in Java, unlike Python, negative indexes is not allowed. In Python, it means that, you know, a negative array index would mean that you would start from the backwards, from the right to the left. But in Java, that is not permitted. You can just go from left to the right. That's it. Because if you give a negative index in Java, what you would get is a negative array size exception. Accessing negative indexes is not at all allowed, and also a negative size array is not allowed. It would straight away give you a negative array size exception. You can There is another way in which you can declare a one dimensional array with the help of characters. You know, let's say int array is equals new int, and within during the time of initialization you can really say small a within square brackets. This denotes that the size of this particular array is 97, since the Unicode ASCII value for small a character is 97. All right. Only int, byte, short, and char data types are allowed to be specified here in the size of the array. You cannot use a long data type. Which brings us to the next point, that the maximum size of an array that you can have in Java is 21474836447. If it exceeds this, then there is a compilation error which shows integer number too large. Okay. Also, if there is not much space present on the heap memory, you might also get a heap memory not available exception. So this is an exception. You might also get this. Very famous exception that I'm going to talk about right now is array index out of bounds exception. What does this mean? This means that, let's say I have an array of size 10, and it is represented by this array variable, and I'm trying to access and store a value 5 in the 11th index of that particular array. This will give me array index out of bounds exception. How to resolve it? Well, you should mention, I have already taught you that, you should mention the index given in the range of that particular array. The range of the array is from 0 to, this is a 0, you should note this, 0 to n minus 1, where n is the length of the array. Alright, so this is it for this video. This is the complete lecture on arrays. I repeat, this is not a data structures video that you are trying to see, but it is intended to clarify all the questions that are there in your mind regarding arrays in Java. See you in the next video, where we will be discussing about operators That'll be a really short video because you already know about operators. I just use them in a couple of programs and expressions, and I'll just talk about the associativity and then do the rest of the work. So thank you for this video. See you in the next one.